Good morning, friends. Welcome back to the class. I hope you all are safe and healthy too. Now, in this session, we are just expanding our previous knowledge of arithmetic progression to discuss some important sums along with some short tricks. So, keep watching this video without any interruption. Now, as you know, the nth term formula and Sn formula of AP that are very standard, like if I am writing this, nth term formula of an AP is generally written as A plus n minus 1 into D. Similarly, the sum of n terms formula will be written as n by 2 into 2a plus n minus 1 into D. So this is the standard formulas of nth and Sn term of an AP. But sometimes you will also see in some question the nth term and Sn formula of the AP will be given in a expression form, like the nth term of an AP is generally expressed in the form of we can say Pn plus Q, and the Sn formula of the particular AP will be given in the form of Pn square plus Qn plus R. So if we observe, look at this expression, look at these formulas of an AP, right? So two things you can easily analyze. The first one is the degree of the nth term formula of an AP will always be 1. You can see n is a variable, P and Q are constants. Here the power of n is 1, degree is 1. Similarly, you may also analyze the degree of the Sn formula will be always 2. So it is linear expression, nth term formula is always linear in nature. Sn formula is always in quadratic in nature. You may also realize this just by multiplying D inside over here. By grouping the like terms, you will always get the AX plus B form, and here by multiplying n by 2 inside, you will always getting a quadratic expression. So hence, what I wanted to say is the degree of the nth term formula of an AP is always 1, and the degree of the Sn formula of an AP is always 2, quadratic in nature. Apart from this, with the help of this formula, you may define the common difference and the value of A, that is the first term and the common difference from this formula, right? So to find the first term, that is the first term, A1, if I want to find A1, just what I need to put n is equal to 1. In a similar manner, if I want to find the first term from this formula, I can simply substitute what n is equal to 1 in the expression. That's it. If I substitute n is equal to 1 over here, the first term will be given by p plus q. And if I substitute n is equal to 1 over here, the first term will be given by p plus q plus r, whatever the p, q, r values may be. And the third is the common difference. The common difference from this formula will be simply the coefficient of n. What is the coefficient of n we have? P. So this will be the common difference. And here the common difference from this formula will be double of the coefficient of n square. The double of the coefficient of n square. So these are the 3 points you may remember regarding when the nth term formula and Sn formula is given to you. So you may just identify first the degree of the formula which is given. If your degree 1 means it's showing the nth term formula of an AP. Degree 2 means it's showing the degree 2 means it's showing what? It shows the Sn formula of an AP. Apart from this, now To get the first term from these formulas, just substitute n is equal to 1. To find the common difference, you may go with the general method also and you may use the short trick also. Both will work. Where the common difference is simply obtained by taking the coefficient of n as it is. Here, to get the common difference from this formula, just double the coefficient of n square. Here we are having the coefficient of n square as p, hence the common difference will be given by 2p. Here I am writing the common difference is given by 2p. Now, with the help of this knowledge, now we are going to discuss few sums, right? Which will help us in very shortest manner. So, here I am taking the question number 7 from the textbook. Question number 7, right? So, what it is given? Find the sum of n terms of an AP whose kth term is 5k plus 1. They were asking find the sum of n terms on in AP whose kth term means AK is given as 5k plus 1. Now see, to find the Sn, I definitely required A and D, and that can easily be determined by observing this expression. As I told you, from the nth term formula, here you can see the degree is 1. Therefore, from this formula, if I want to read the common difference, that is simply the coefficient of k, that is 5. Get it? And to get the first term, if I want to find the first term, simply I need to substitute k is equal to 1 in the right. To find this a, just what I substitute, k is equal to 1. So a1 will be 5 into 1 plus 1, that is 6. So from this formula, first I will be able to find a and a directly, and then I can use a regular formula to find Sn. So n by 2 into 2a plus n minus 1 into d. Just substitute these values over here to get Sn. Sn will be n by 2 into 2 into 6 plus n minus 1 into 5. Just by simplifying further, you will be able to get the final answer. N by 2 into 12 minus 5, that is 7 plus 5. So this is the nth term of an AP whose kth term is in the form of 5k plus 1. So friends, it's so simple to now getting the answers if we are using that tricks, right? So in a similar manner, if I go with the question number 8, I'm just directly solving over here. It's a single step answer. Sum of the n term formula is given. Question number 8. The sum of the n terms of an AP is given as Qn square plus Pn. Right? Where P and Q are constant, find the common difference. It's so simple as I discussed. Sn degree is 2. It's a quadratic in nature. And the coefficient of n square is q, hence the common difference from this formula will be double of this value, that is 2q. Question is over, right? Now with the help of the same concept, now we will discuss the question number 13 also in parallel. Question number 13, what is given? If the sum of n term formula is given again, sum of n term formula is 3n square plus 5n, right? And mth term is given as well. They have given the mth term am is equal to 164. Find the value of m. This is the question. Just look at again the expression here. From here, if I put n is equal to 1, so definitely the first term of the sequence is given by 3 into 1 square plus 5 into 1. Hence the first term of the AP is 8. Now common difference is double of the coefficient of n square as we were discussing, that is 6. Now as you know the first and the common difference, then use this expression mth term. It means that a plus m minus 1 into d, where mth term value is given as 164, a is 8, then m minus 1 into common difference is 6. So 164 is equal to 8 plus 6m minus 6. So 164 is equal to 2 plus 6m, or 6m is equal to 162. M will be divided by 2, so 6 2s are 12, 6 7s are 42. The required value of M is 27. So friends, here with the help of the some logics and short tricks, we were able to solve question number 7, question number 8, question number 13 like questions in a simplest manner. Now, in a similar way, now we are going to discuss two more sums where again the another short trick is involved. Let's see how it will work. Yes, what we have, right? Now, what they have asked that question number 9 I'm talking about, right? Question number 9. The sum of the n terms of two arithmetic progressions are in the ratio 5n plus 4 upon 9n plus 6. Find the ratio of their 18th terms. See, sum of n terms of n two arithmetic progressions. So there are two arithmetic progressions. First, let us say AP1, AP2, right? So whose first term is denoted by A1, the common difference is denoted by D1, first term is denoted by A2, common difference is denoted by D2. So therefore, the sum of n terms of this AP will be given by n by 2 into 2A1 plus n minus 1 into D1. And here the sum of n terms of the second AP will be given by n by 2 into 2A2 plus n minus 1 into D2. This is the sum of n term formula of second AP, and this is the first AP. The ratio of their terms means Sn of AP1, sum of n terms of first AP to sum of n terms of second AP is given as 5n plus 4 by 9n plus 6. Now, with the help of this expression, what they have asked, find the ratio of their 18th terms. What they have asked? They are asking like find the 18th term of first AP to 18th term of the second AP, that is A1 plus 17D1 to A2 plus 17D2 value. What they have asked? The 18th term of the first AP to 18th term of the second AP. So now just this is what the given thing. With the help of this expression, we are going to find this value and simply substitute these formulas over here. First, n by 2 into 2a1 plus n minus 1 into d1 by n by 2 into 2a2 plus n minus 1 into d2 is equal to given as 5n plus 4 upon 9n plus 6. So n by 2 get cancelled. Now, from this expression, how to get a1 plus 17d upon a2 plus 17d2 is, it's simply, if you observe that if we were looking for the ratio of 18th term, right? So we are looking for ratio of 18th term. To get the ratio of 18th term, just we need to substitute the value of n as double of the term we are looking for minus 1. So what we need to substitute over here is double of 18 is what? 36, right? And then minus 1, that is what? 35, right? So ultimately you will get, say, what you are going to get is 35. So this is what we called as short trick. But all you must know, every short trick is developed just by observing the concept and the pattern. Nothing else, nothing is magical over here, right? So everything is well defined. Only you require some logics in the simplification to get the final answer. So n is means here just double of the term minus 1, that is 35. If we want to find the fifth term ratio, so 2 into 5 minus 1, that is will be 9. So this is what the logic is. So what I need to put here 35 in the expression, in above expression. So ultimately in the next step what I am going to get is C, 2a1 plus 35 minus 1 will be 34d1 upon 2a2 plus 34d2 is equal to 5 into 35 plus 4 upon 9 into 35 plus 6. So now you can take 2 as a common factor and that will be get cancelled also. So a1 plus 17d1 upon a2 plus 17d2, which is equal to, just multiply these two values and add them. So 5 5 is 25, 2 5 is 15 plus 2, 175 plus 4, 179 by 45, 4, 27 plus 4, 31, right? 31, and I am for 40, 315 plus 6, it will be 321. So the required ratio will be, 179 is to 321. So friends, here you can understand, only the thing is the sum of the n terms of an AP is two different APs are given in an expression form. With the help of this, we are going to find the ratio of the corresponding terms. If it is a 18th term they are asking, you need to substitute n is equal to 35. How you will get this idea? Just double this value and subtract 1. If it is a fifth term, double the value, that is 10 minus 1, that is 9. Just substitute n is equal to 9 in the expression to get the required ratio. So this will serve you the better one. Now, with the help of the same concept, now we are going to discuss the next sum. We'll see. Right. So with the help of this, now we can able to solve the question number 12. The ratio of the sum of m and n terms of an AP is only single AP. It is a single AP based question whose first term will be A and common difference will be D. Right? So what they have said, the ratio of the sum of the m terms to the sum of the n terms is given by n square by n square. This is the given. And show that their mth term and nth term will be, means to prove what they're asking, the ratio of mth term and nth term will be 2m minus 1 upon 2n minus 1. That's, I repeat, in an AP, the ratio of the sum of the m terms to the sum of the n terms is given by m square by n square. Then find the ratio of mth term to the nth term will be 2m minus 1 by 2n minus 1. We have to show this ratio will be this. Okay. So first of all, we'll go with the general one. The sum of n term formula of the AP is given by m by 2 into 2a plus m minus 1 into d upon n by 2 into 2a plus n minus 1 into d is equal to m square by n square. So 2 get cancelled, and this m will go in denominator, this n will go in numerator, hence 1n and 1m will be get cancelled. So we are left with 2a plus m minus 1 into d upon 2a plus n minus 1 into d is equal to n by n. And what is the ratio we are looking for? We required the ratio as 2m minus 1 upon 2n plus 1. It means that in place of m, I require 2m minus 1. In place of n, I require 2n minus 1. That is only what we are going to do. So put m is equal to 2m minus 1 and n is equal to 2n minus 1, as this is simply following the logic which I have explained in the previous sum. Whatever the ratio of the term you wanted to get, just double that value and subtract 1. So mth the term you required means double of m is 2m minus 1. Nth the term value required, so double of n minus 1. So in a similar, by using this logic, directly I will be able to get the final answer. So what I am going to get, see, 2a plus, in place of m, what I am going to write, 2m minus 1. So ultimately the expression becomes 2m minus 2 into d upon 2a plus. In place of n, I am going to write 2n minus 1. So ultimately expression becomes this. Ultimately it is what, 2m minus 1 by 2n minus 1. Now if you observe, 2 is a common factor from entire expression. When you take it out, what is left? A plus n minus 1 into d upon a plus n minus 1 into d, which will be equal to 2m minus 1 by 2m minus 1. Hence proved. See, it's so simple to prove if you just follow a small tips in the expression, nothing else. So this is all about the today's session. So I hope it definitely help you out to complete the exercise apart from the arithmetic mean, and arithmetic mean will be discussed in the next consecutive video. So keep watching, keep learning and keep going. Thank you all of you for watching me. Okay, so be safe, be healthy. Bye bye.